Hey guys, welcome to this next video. We're going to be looking at tree diagrams. Okay, and our learning goal for this one is that we're still looking at that determining the probability of experiments where there are multiple events. And at the end of this, we want to be able to construct a tree diagram to determine the sample space and calculate the probability using the sample tree. Sorry, the tree diagram. All right, so coins of chance. Now, if we've got sort of a repeated trial over and over again to find the probability after certain numbers of trials with a particular outcome, you multiply those set of probabilities happening over and over again. So for example, if we're tossing a coin 10 times, okay, so the probability what's the probability of heads times 10? So 10 heads coming from 10 coin flips. Okay, so it's an interesting one. So we've got to think about our favourable over our total. Okay, so there's only going to be one time this happens. You get your heads out of all of your possible outcomes. That all of them will end up being heads. And so you think to yourself, okay, well, how am I going to work this out? Now, your total, you may not be sort of aware of how it works, but for this one, it'll be 2 to the power of however number of times you toss it, right? But you can also draw out sort of a tree diagram. So it's something to have a look at it in a little bit. So, we've tossed the coin. Our first one could be heads and tails. And then our next one could be heads or tails. And this one could also be heads or tails. And then this next one could be heads or tails, and etc, etc, etc. It ends up going down, so you'll end up having 1,024 different possibilities happening in the end. Okay, so there is a 1 in 1,024 chance that this will happen. So really, you'd have to be tossing coins all day to get this. Well, maybe not all day, but for a while to get this to happen. Okay, so these tree diagrams are another way to sort of visualize all the different outcomes and sort of how they branch off and how the different probabilities are related to each other. And this one works, as you'll see, for when we got more repeats or events than just the two, like our arrays. Okay, so our key ideas. Tree diagrams can be used with multi-stage experiments, like we've already seen, with 2 or more steps. That's the important part. Okay, now outcomes are listed vertically, and each stage is connected with a set of branches that sort of correspond to the number of chances. Okay, also the chance that it will sort of land on that new thing. Okay, so let's have a look. A coin is getting tossed 3 times. And this is important, that replacement is okay. What that means is that the same event can come up more than once. So just because you toss the heads for the first time, it doesn't mean you're not allowed to toss the heads anymore. Okay? So we say to ourselves, right, we have so our first possibility is a heads or a tails. There's our event 1. Then, as we sort of saw above, our next split is into a heads and a tails again. Heads and tails. And then again, we have a heads and a tails, and a heads and a tails, and a heads and tails, and then heads and, unsurprisingly, tails. Now, once you've got this, you want to write down all your events, your outcomes at the end. So this is tossing heads, heads, heads. This is heads, heads, tails. This is heads, tails, heads. This is heads, tails, tails. This is tails, heads, heads. Tails, heads, tails. Tails, tails, heads. And tails, tails, tails. Alright, so let's just put a line here to sort of separate this. Oh dear, that was terrible. Okay, right, round 2. There we go. Okay, so we've got 1, 2, 3, 4, 5, 6, 7, 8. So the total outcomes is equal to 8. Okay, now, so sort of how this works is like, well, what's the probability of tossing at least 2 heads? Okay, so you can go through here and we look, right, when we get 2 heads, here, 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 and that's it. So we can toss at least 2 heads, 1, 2, 3, 4 of the time. So got a favourable over total, favourable is 4 times, our total is 8, so that means half the time we should expect to get at least 2 heads out of our total number of sort of outcomes, alright, events. So that's sort of how a tree diagram works. They can get big and crazy, but it's sort of important to just make sure you are ensuring every event sort of gets done at each stage, okay? Alright, now the other type is when we have no replacement, which is where the same thing can't happen again once it already happened. So imagine for yourself a bag containing 1 red, 1 blue, 1 green marble. Right? Super exciting, yeah? So this one we have no replacement. So once you've drawn a marble out of the bag, you don't put it back in there to draw back out again. Okay, you pick it out and place it next to you. Okay, so our tree diagram is going to look a bit different. So we've got, from our start part, we've got 3 options. So 1, 2, 3. We could either draw out a red, a blue, or a green. Okay. Now, with our red, that's one of the marbles is gone now, and so the only ones left to be able to draw out is a blue, and then a green. Okay. And then at the end of that one, the only thing left after this is going to be the green. The only thing left after this one's going to be the blue. With this one here, we've got blue. The only thing that's going to be left will be a red or a green, and then the only thing to be left will be the green or the red. This one here, we have the red or the blue, and this one has the blue, and this one has the red. And so our outcomes in the end will be red, blue, green, red, green, blue, blue, red, green, blue, green, red, green, red, blue, green, blue, red. Okay, so that's how we set these ones up. Now, and the probability question for this could be something like, what's the probability of getting a green by the second pull from the bag? Okay, so we got the favourable over the total. And because we've got these in order, this is going to be easy. Right, when do we get a green in at least one of the first 2 ones? So we get it here, and here, here, and here. Okay, so that is 1, 2, 3, 4 favourable events. So let's just down a little bit here. So that'll be 4 favourable over our total. Oops, didn't write that. 1, 2, 3, 4, 5, 6. So our total is 6. 4 over 6, which is simplified to 2 over 3, and that's our probability. So 2/3 of the time, by the second pull, we will have got the green one out of the bag. Okay, so these tree diagrams, again, it's going to be about practice, especially with the idea of when there's no replacement. That's some stuff that can get a bit of thinking involved, well, some heavy duty thinking. And please, if there's some things you didn't understand, come see me straight away so we can sort that out. Okay, thanks so much.